Section 9.4 is on ellipses. The definition of an ellipse is the set of all points in a plane such that the sum of the distances from two fixed points is constant. Those two fixed points are called foci. That's the plural of focus. Let's take a look at a video that I found that kind of shows what this definition means. So here's an ellipse. It looks like an egg shape, and the 2 points right here, the end of this blue line on the left, and you can see a little bit of the little red line right here. Those are the foci, the two focuses. And what the definition says is that the length of the blue line plus the length of the red line is the same when you add them together as it moves around like this. So the sum of the red plus the blue is the same all the way around. Just kind of a cool little image. Okay, let's get back to some more vocabulary here. So every ellipse has two axes. These are lines that go through the center of the ellipse. They're perpendicular to each other. The major axis is the longer one, and its endpoints are called vertices. The minor axis is the shorter one, and its endpoints are called covertices. And an ellipse has either a horizontal or a vertical orientation. So a horizontal orientation is going to be like this, more like in line with the x-axis, and a vertical orientation is going to be going more up and down like this one here, more in line with the y-axis. Here's a whole bunch more information, and it looks a little overwhelming, and I wouldn't worry about memorizing all of this because we're going to be able to work through a lot of it and as we actually graph some of these. So one of the main things you need to know here is to be familiar with the equation for an ellipse. So there's two different forms. So for the horizontal one, it's this first one, and for a vertical ellipse, it's this one right here. So you have x minus h squared over a squared plus y minus k squared over b squared equals 1. Notice that in this one, this is horizontal, and a is underneath h. I'm sorry, a is underneath x. So x, think of that as the horizontal axis. A is always going to be larger number than b. Okay, so this is the one for the horizontal. A vertical ellipse is going to be y minus k squared over a squared. Notice the y is over the a, plus x minus h squared over b squared equals 1. Also notice that both of these equal 1, and we have addition between them. In fact, if you look at this, the top part of the numerator of each equation looks a lot like the equation of a circle. So this number a down here is going to be the distance from the center of the ellipse to the vertex, to a vertex, and b is going to be the distance from the center to a covertex. So that means that the length of the major axis, the longer line going through the middle of the ellipse, is going to be 2 times a units long, and the length of the minor axis is going to be 2 times b units long. We have equations here for the coordinates of the foci, vertices, and covertices, but actually we're going to be able to kind of count and figure out what those are. One of the main things you need to know about the foci is that they are c units from the center along the major axis. Another key thing on this page is the relationship between the values of c, a, and b, and that is c squared equals a squared minus b squared. And so that means that a is always going to be greater than b, and that's an important thing to remember. So let's before we dive into a couple examples, here's some images from your textbook that kind of show where all the different things are. Main thing is this one is a horizontal orientation, the bottom one here is a vertical orientation. Remember, the longer line is the major axis, the shorter line is the minor axis. Vertices are on the ends of the major axis. Covertices are on the ends of the minor axis, and the center, of course, is in the center. And actually you can see from this diagram here that these 2 points here labeled F, those are the foci, and you can see that those are c units from the center. Okay, now let's dive into a couple examples. So for this one, we're given the graph of an ellipse, and we need to write its equation. So basically we need to know what are h and k, what are the center, and then what are the values of a and b. And we can get that just by looking at the graph here. So let's go ahead, and I kind of like to draw in the two axes. So this one has more of a vertical orientation, so that's going to be my major axis going up and down. my minor axis is going to be going from left to right, and the center is right here. So my center is the point, what is that, -2, -1. So that means h is -2 and k is -1. Now if we look at this, my major axis is going up and down, so that means this has a vertical orientation, which means that y is going to go over my a. So a is this distance here from this vertex to the center, and that is 1, 2, 3, 4, 5 units long. So a is 5, and b is going to be basically half of the minor axis, or from the center to a covertex, and b is going to be 3. Now remember, the formula I'm going to use is y minus k squared over a squared, okay? And it's y over a because it's vertical, because it's going up and down, plus x minus h squared over b squared equals 1. So now we have our hk, a, and b. We can just plug those numbers in. So y minus a -1 squared over a squared, which is going to give me 25, plus x minus h, so that would be minus a -2 squared over b squared, 3 squared is 9, equals 1. And that's the equation for that ellipse. Okay. The next two examples ask us to write an equation for an ellipse that satisfies each set of conditions. And in this case, we're given the coordinates of the vertices and the coordinates of the covertices. So you can do this algebraically using those formulas on one of the previous pages, but it's actually a whole lot easier if you just kind of graph it. So we have vertices at -7, 2, 3, 4, 5, 6, 7, 4, and 1, 4. And then we have covertices at -3, 2, and -3, 6. Did I count right there? I think so. Okay, so those are so my ellipse is going to look something like this. Didn't ask us to graph it, but I think it helps to graph it. Okay, that looks a little bit more like an eye instead of an ellipse, but you get the idea. So this here is going to be my major axis, because it's longer. This one here is my minor axis, and just by drawing those in, I can get the ordered pair that represents the center, and that's -3, 4. So my center is at -3, 4. So when I go to write my equation, my h is going to be -3, and my k is 4. Okay, this one's going to have a horizontal orientation because the major axis is horizontal. So that means that the distance from the center to this vertex is 4 units. That's my A. So A equals 4. And then the distance from the center to a covertex is 2. So that's going to be my B. And my equation, since it's horizontal and kind of goes the direction of the x-axis, my equation is going to be in the form x minus h squared over a squared, okay, because a is bigger, goes over, or goes under the x, plus y minus k squared over b squared equals 1. And I basically have all my information, I just need to plug those values in. So final answer, x minus a -3 squared over a squared, which is going to be 16, plus y minus k squared over b squared is equal to 1. And that's the equation for that ellipse. In this example here, have to write the equation again. We're given the coordinates of the center, one vertex, and one covertex. And as we did in the previous example, let's go ahead and graph those. So my center is at 3, -4, and I have a vertex at 8, -4. So 3, 4, 5, 6, 7, 8, -4. I'm going to just put little letters there. That's my center. That's a vertex and a covertex at 3, -2. That's a covertex. Okay, so from this I can see that this is going to be, my major axis is going to be horizontal or in line with the x-axis. So I could actually draw another vertex that would be the same number of units on this side, and my minor axis is going to be shorter this way. But let's get the coordinates of the center. My center is, oh, actually I already have that. They gave me my center. So my h is 3, my k is -4. So all I really need now is my a and my b. So this distance here, this is going to be half of my major axis, and that's 5. So a is 5. This is going to be half of my minor axis. That's b, which is 2. Since this has a horizontal orientation, I'm going to have x over a. So x minus 3 squared over a squared, so 25, plus y minus -4 squared over b squared, which is 4, and that equals 1. And that's the equation of that ellipse. Now our next two examples say, find the center, the foci, and the lengths of the major and minor axes for each ellipse, and then graph. So let's see, let's take a look at this equation. So I have x squared over 25 plus y minus 3 quantity squared over 36 equals 1. So notice that 36 is larger. That's got to be my a squared, and that's under the y. So this is going to have a vertical orientation. Okay, and I can read off some of these values here. So my h is going to be 0 because that's the same as x minus 0 squared. My k is 3. A is going to be the larger number, so a squared is 36, so a is 6, and b is going to be 5. Okay, so my center is the point 0, 3, and maybe I'll go ahead and graph that. Okay, I know that a is 6. That's going to be half of my major axis, and since this is vertical, that means I'm going to go up 6 from my center, and I will go down 6. Okay, that's my major axis is vertical. My minor axis is 5, so I'll go out 5 in each direction. Okay, could actually draw it now. Okay, so let's see. So we have the center. The length of the major axis. So this major axis going right here is going to be 12 units long. 6 from a vertex to the center and another 6 from the center to the other vertex. My minor axis is going to be 10 units long. That's this horizontal line right here. Now we need the foci. In order to find the foci, I'm going to have to do use that equation. So c squared equals a squared minus b squared. Because remember, c represents the distance from the center to each focus. So c squared is equal to 36 minus 25, or 11. That's c squared, so c is equal to the square root of 11, which is approximately 3.3. Now, in order to find the coordinates, I could go through that complicated formula, but I'm just going to use the graph and I'm going to count. So the foci are along the major axis, so in this case that's actually the y-axis, and they are 3.3 units from the center. So approximately there, and 1, 2, 3, and a little bit, and approximately there. To get those coordinates, notice they're going to have an x-coordinate of 0. Okay, and I'm just going to count up here. So that's 3, 4, 5, 6, and that was 3/10. So 6 3/10. And my other one is also going to be 0, and it's this point down here, and that's going to be a -3/10. And those are my foci. And our last example here is a little more complicated because we're given the equation of the ellipse in general form and we need to put it into standard form. So we're going to have to do as we did with equations of circles and do the little completing the square trick. So the first thing I want to do is put my x's together. I'm going to leave a little space. Let's put my y's together. And move my constant to the other side. Now, in order to complete the square with my x's and with my y's, I need to get rid of the leading coefficient. So I'll factor out a 9. And I'm going to leave a space for my new value of c. Oops. With my y's, I need to factor out a 16. Leave a space for my new c, and that equals 71. So my new c is half of b squared, so that's 1. But when I put a 1 in the parentheses, I didn't really add a 1, I really added a 9 because that 1 is being multiplied by 9, so I need to add that 9 over here. Half of negative 4 is negative 2 squared is 4. So when I add a 4 inside the parentheses, I really added 4 times 16, which is 64. So now I can factor these trinomials. And that adds up to 144. Now remember, the equation of an ellipse has to equal 1, so I'm going to divide everything by 144, and it actually is going to work out. So 9 times 16 is 144, so this is going to give me x plus 1 squared over 16 plus y minus 2 squared over 9 is equal to 1. Okay, now from this, it's actually pretty straightforward. I can get the coordinates of my center are going to be negative 1, 2, and a is larger, so my a is going to be, 16 is a squared, so my a is going to be 4, and my b is going to be 3, and I think I'm going to go ahead and graph. And I'll worry about the foci in just a minute. So I have negative 1, 2, and since my larger number is under x, this is going to have more of a horizontal orientation. So from the center, I'll go 4 to the right and 4 to the left. And for my minor axis, up 3 and down 3. And I'll go ahead and connect those. All right. And let's see, so I need to say how long my major axis is. So my major axis is 8 units long, 2 times a. My minor axis is 6 units long, 2 times b. And now I need to find the coordinates of the foci. So I'm going to do c squared equals a squared minus b squared, which is, I'm going to give myself a little more room here. There we go. Or 16 minus 9, or c is going to be equal to the square root of 7, which is approximately, what did I figure that out to be, 2.6. So I'm going to graph those on here. Now in this case, because this ellipse has a horizontal orientation, the major axis is horizontal, so my foci are going to be along there, and they are 2.6 units, looks close to 2.5 from the center. So those 2 points there are my foci. To find their coordinates, I'm just going to count. So this is 1 and, that would be what, 1 and 1/6, or I'm sorry, 1.6, comma 2. And this one is going to be negative 1, negative 2, negative 3.6, comma 2. And those are the coordinates of my foci. So in this lesson, we took a look at ellipses. We learned what the equation is and how to find the length of the major axis, the minor axis, the center, the coordinates of the foci, and all sorts of other fun stuff.